So, have you taken a look at your company's cloud bill lately? If you have, you've probably noticed something, well, kind of terrifying. Costs are just exploding. And the number one reason, the main culprit, is artificial intelligence. For years, the cloud was the answer for everything. It was scalable, efficient, and best of all, predictable. But now, in 2025, AI is completely shattering that model. Okay, let's dive into this and figure out exactly why your cloud bill is going through the roof and what this AI cost crisis is all about. Let's just kick things off with a number that really sets the stage for this whole problem: 165%. According to Goldman Sachs, that's how much the power demand from data centers is going to shoot up by 2030. And the main driver behind this massive surge? Yep, it's AI. We're not just talking about a little software trend here. This is a fundamental shock to our entire global energy grid. It's huge. And this leads to something that's kind of wild when you think about it. As IT consultant Tom Lawrence says, cloud becomes technical debt. The very platform that was supposed to get rid of our infrastructure problems is now becoming a huge financial weight for so many companies. Everyone moved to the cloud for flexibility, right? But the constant, intense demands of AI are turning that flexibility into a wildly unpredictable and, frankly, unsustainable expense. So here's our game plan for this explainer. First, we're going to look at the incredible scale of the AI cost shockwave. Then, we'll dig into the techie reasons why AI actually broke the cloud model. After that, we'll get into the infrastructure reckoning that's forcing a total rethink of data centers. We'll even touch on the unexpected comeback of on-premise solutions. And then we'll wrap it all up with some real strategies for taming your AI cloud bill. All right, let's jump into our first section, the AI cost shockwave. And I'm not kidding. This isn't just some small budget bump we're talking about. For a lot of companies, AI has gone from being a little line item to a full-blown crisis on the balance sheet, forcing them to completely rethink their entire game plan. Let's actually put some numbers on this. I mean, look at this. The overall public cloud spending is gigantic. It's set to hit almost $750 billion in 2025. But the really interesting story is what's happening inside that number. The average monthly AI budget for a company jumped 36% in just 1 year. AI is officially out of the experimental lab phase and on the factory floor, and it is taking the company budget right along with it. So why is this happening? What is going on? Well, that brings us right to our next section, why AI broke the cloud. And the heart of the matter is this: AI workloads, especially for things like large language models, are just different. They have this bottomless, insatiable hunger for a very specific and very expensive type of computing power that the traditional cloud just wasn't built to handle. This table just shows the hardware arms race perfectly. I mean, just look at the jump from NVIDIA's A100 chip to the H100 in only 2 years. The memory bandwidth is up over 60%, but the real game changer is that transformer engine in the H100. It's literally designed for the exact kind of math that powers these huge AI models. This isn't just a small step up, it's a massive generational leap in hardware. And let me tell you, that leap comes with a seriously hefty price tag. And here's what that leap looks like in the real world. The H100 can process more than double the number of tokens per second compared to the A100. Now, if you're using something like a real-time chatbot, that's the difference between a conversation that feels totally natural and one that's painfully slow. But to get that speed, you need way more power and much more complex systems, which, of course, drives up the hourly cost to rent these things in the cloud. It's not just one thing, it's a perfect storm of costs. First, you've got that raw hunger for GPUs we just saw. Then you have unpredictable scaling. You've got teams just firing up AI tools without getting approval, something people call shadow AI. Plus these pricing models based on tokens that are almost impossible to predict. Throw in the massive strain on energy and the fact that the hyperscalers are spending up to $370 billion on new infrastructure this year, and guess who that cost gets passed on to? You. And all of this leads us to a much bigger problem. Our third section, the infrastructure reckoning. The actual foundation of the cloud, the physical data center, is being pushed to its absolute breaking point. The demands of AI are forcing a complete and total redesign of how we power, cool, and even build these giant facilities. Get this. A normal server rack might use, say, 5 to 15 kilowatts of power. A modern AI rack, just stuffed with GPUs, can already blow past 100 kilowatts. And the projections show we could be heading towards a mind-blowing 1,000 kilowatts per rack by 2029. That is insane. This isn't a problem you can solve with just bigger fans. This requires brand new electrical systems and a massive move to liquid cooling. So, what are the big cloud providers doing about it? Well, they're starting to build their own custom chips. Amazon has Trainium, Microsoft has Maya, and Google's been at this for a while with their TPUs. By designing their own silicon, they can fine-tune performance for their specific AI services, they can rely less on a single company like NVIDIA, and they can get way more control over their own costs and supply chain. And all of this leads to this new concept of AI factories. We're not just talking about upgrading old data centers anymore. No, this is about building brand new facilities from the ground up, designed for one thing and one thing only: AI. They've got the super fast computing, the high-speed networking, and new kinds of storage, like vector databases, all optimized to run AI at a scale we've never seen before. Now, all of this cost and complexity in the cloud is causing a really surprising trend, which brings us to our next section: on-prem's unexpected comeback. I'm serious. Companies that spent the last decade moving everything to the cloud are now actually thinking about moving some of it back out, just to get some control and predictability back. This is the key question. It's the billion-dollar question that CIOs and CFOs are losing sleep over right now. For years, the default answer to everything was cloud first, but the insane economics of AI are forcing everyone to hit pause and rethink. The tipping point seems to be when your cloud bill for a steady, constant workload starts to hit around 60 or 70% of what it would cost to just buy and own the hardware yourself. So the decision today isn't just a simple cloud versus on-prem choice. It's really about a smarter, hybrid approach. The cloud is still the king of elasticity. It's perfect for experimenting, training models, and handling those sudden spikes in demand. But for a consistent, high-volume AI job that runs 24/7, the math is starting to show that it's just cheaper to bring it back in-house, where the costs are fixed and predictable. And hey, this isn't just a theory, it is happening in the real world. Take a look at this case study from the virtual events company Passage. By moving their big GPU workloads away from one of the major cloud providers to an alternative, they slashed their cloud spending by an average of 50%. It just goes to show that massive savings are out there if you're strategic about where you run your workloads. This quote from John Doss really hits the nail on the head. You don't actually save money by just adding a new system, whether that's in the cloud or on-prem. The real win comes when you can finally turn off the old expensive thing. If you're not planning to retire the old system, you're just planning to run two systems at once, and that just means more complexity and more cost. Okay, so we've laid out the problem, we know the causes, we see the big shifts happening. Let's get to the good stuff. In our final section, taming your AI cloud bill, it's time to move past the sticker shock and build a real, actionable strategy. The good news is the cloud providers themselves are starting to roll out tools to help. Let's take AWS Bedrock, for instance. They've got features like prompt caching that can cut costs by up to 90% just by reusing common bits of text. They have model distillation, which lets you use smaller, way cheaper models for certain tasks. And they've got intelligent routing, which can automatically send your request to the cheapest model that can get the job done. These are powerful tools you can use right now. But beyond the specific platform tools, you have to think bigger. You need to adopt what's called a FinOps mindset for AI, basically bringing financial discipline to your tech. That means you start tracking the cost per query, not just the giant monthly bill. You can use cheaper spot instances for jobs that aren't super urgent. Instead of costly fine-tuning, you can often use smaller models with a technique called RAG, which gives them access to your data. And definitely explore using multiple clouds to avoid getting locked into one vendor. Let's end this section with another great quote from John Doss, because it's the ultimate reality check. At the end of the day, all the cool tech and fancy features don't matter if your costs aren't going down. The absolute best measure of a successful modernization plan is a reduction in your costs, period. That frees up money to innovate somewhere else. And that leaves us with one final big idea to chew on. For decades, the tech world has been obsessed with one thing: the speed of the computer chip. That was always the bottleneck. But as AI continues to scale, we are entering a totally new era. The biggest challenge is shifting from raw processing power to raw electrical power. So as you plan for your AI future, you have to ask yourself, is your biggest bottleneck the chip, or is it the plug in the wall? That question is going to define the next decade of technology.